share my screen. Can you all see my screen?
Yes.
All right, let me All right, let's see. Welcome, everyone. Let's see. So looks like quite a few of you have been already been working in the Mongo database assignment, and you've been asking a couple of questions and pointing out a couple of syntax errors, which I have since fixed. I just want to point them out. I believe way towards the end, the very last few statements, I had skipped over a couple of curly brackets. So that curly bracket right here, I added it. Right, that was missing, and also there was a missing curly bracket right there. One of the students point that out, so I fixed that. Also, this economics is supposed to be in double quotes, and they were not, so I fixed that. Other than that, there were some folks were reporting that they could not do the dump the database, and from what I can tell, especially from students that came to the office hours, and most of the problems were because they had not yet downloaded the tools. So if you go to the website that it's linked from the assignment, it takes you here to various tools, and here if you go to database tools, you can download the tools, and that's a zip file that you can that contains all the tools that are they used to be provided as part of the main installation for Mongo, and now they have since divided it into like the main server as a separate download, and then the tools as a separate download. So now you have to download both of them. It used to be one single install, but when you download it, the tools, you get this zip file, right? And in that zip file, if you go in the zip file, there's a bin directory there, and you can find all the tools there. See that? So what you could do is just copy this into wherever your server is already installed, right? Because you might have put the bin directory already in the path. So you can just copy these, and then in a separate wherever you installed it. So for me, I have it under program files, MongoDB server, and then bin right here. So what I did is I pasted all my tools under here. So there it is: Mongo dump, Mongo restore, import, export. All these used to be here in the main server installation, but now again they're separate. So what I did is I downloaded separately, and then I moved them here. And then in the environment variables, right? Because since for me the Mongo bin directory is already part of the path, anything I put in there will be part of the console. And I helped a couple of students in office hours yesterday on Windows and on Mac, and we were able to get it to run. So I know it works not only in my machine but in other folks' machines if it's configured right. So just command line is it's something that at some point you have to start feeling comfortable with. Many of the more interesting tools for development are command line based, and you're going to be with tons of other folks in the industry that that feel just very at home at doing all sorts of command line commands and options, and so yeah, that's definitely a skill you want to practice. Let's see. So that's the Mongo tools. Also, some students were reporting that they could not find the shell, the DB shell that the assignment references. The assignment asks you to find the DB shell. So DB shell, yeah, the DB shell, and I explained here in the assignment that you can find it in the home directory. That's what the squiggly line means. The squiggly line means that it's under the home directory. So the client will. So I guess maybe I should put it here under your home directory. Okay. So this is well, or some folks refer to as the profile directory, your profile. So on Windows, you can get there if you go to C. You go under users. This is you right here. That's my home directory, and the DB shell will be there. See that DB shell? Now, because it's a dot, it has a dot in front of it. It might hide the file. It would be a hidden file. So you might need to say show hidden files or something. Yeah, files with extensions, hidden items. So you might need to select the hidden item so that it actually shows the file. Like if I uncheck it, oh, it still shows it actually. Yeah. So make sure that you can see that. If you open it up, it's you'll notice that it contains all the commands that you typed in Mongo at the client, right? And this is great for for the TA to look at that you actually did execute all those commands at the console. Okay. Let me see. Is there a question in the chat? Hello, Professor. Where's everybody? Fundies 2 midterm really did some damage. Oh, Fundies. Yeah, Fundies is tough. Not only funded, but feeling bad for that again. I boomed my midterm. Yeah, okay. On a Mac, also you will find it at the home directory. In your home directory, that's where you find it. In your home directory, typically it will be listed on your on the left-hand side. For instance, for me, it's this one, Jose Annunziato. And in here, I see my DB shell listed there. On a Mac will be the same way. You'll have a home directory. If you click on it, you'll have the DB shell under there. Okay. So we're asking you to include your DB shell and your dump the database using the command dump, Mongo dump, which is listed down here. Extract the database, so Mongo dump. So you need to do this. Well, really, you can do it from anywhere, but I think the best thing to do it is inside the directory where you did all your work. So let's go in there. So if you go to CD documents, NEU database design 04. So if you go to your Mongo assignment, this is where you would do the dump. Now to do the Mongo dump, you need to have the server up and running, right? And if you remember, yesterday we set it up so that I'll make this a little bigger. There you go. So yeah, so we created this data directory where the database server is writing all the data. Okay, and so the way we configured it is that we can run the MongoD. Now MongoD all by itself is going to fail, right? Because it needs to know where to put the database, all the data. So that's going to fail. You need to tell it where, DB path, and it's this data directory that we created, right? So now it's going to start up and it's going to listen at port 27,000 something or other. I forget. Yeah, there it is. It's listening at port 27017. Now, if you absolutely are, don't know how to use the command line, you can still start the server without setting the path and updating it. If you remember where you install your bin directory, like for instance, for me, it's under program files, right? Under Mongo, then server for bin, see that? And then under there, you have MongoD. There it is, MongoD. So here, you can still start the server if you know where it is exactly. And if you really don't know how to use the command line, you can still run it like this, right? And then you say db path, and then point to data. So this will also work. Okay. Once the server's up and running, you can leave it alone, and then you can go and do the Mongo client and do and run the tools. Right. So let me start up a new PowerShell. And again, let me make it big so you can see what I'm doing. Okay, so let's go back in the documents and the design of 4 and Mongo data. Okay, so in here we can start the Mongo client. Again, you could do program files, MongoDB server, blah, 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 4 server, and then run Mongo. Or if you've successfully added it to the path, you can just run Mongo that, right? So Mongo's running, and also you can also run the tools from here, right? Well, not from Mongo. Like, I'm going to start up a new PowerShell just to show you. Well, actually, no, let's do it from here. I just quit, and so you can do the dump. Actually, let me in Mongo. I think we show DBs. What we worked on this one, DB whiteboard 4. Let's see what we had there, right? We had we said use, and then we had a couple collections in here, right? We had sections and users, and we had DB sections dot find pretty. So this is all the data, and we want to dump all this data, and so we can use Mongo dump, right, as shown like this. And now the database that we have, it's called whiteboard 04. So let's dump that, right? For you, but in your assignment, you're going to create your database is going to be called db_design. So, but let me just show you. You say Mongo dump, and then db would be whiteboard 04, I believe. Right. So what that does is that it creates a brand new directory. See that dump. So we go to dump. There it is. See that whiteboard 04, and in there, oops, you'll see that it'll dump all the users and all the sections. Okay, in a binary format. It's like a binary JSON format. So it's like a compressed, smaller version of JSON, which removes all the white spaces, and it compacts it so that it's easier, so that it can be stored in a smaller file. So what we're asking you to do is to go and just zip up this directory, this dump directory, put it in a zip file, and then submit that. So submit that and submit the shell, those 2 files into as part of your Canvas deliverables. Did that make sense? Anybody have a question on that? All right. Okay. All right. Good. So let's keep going. Let's review where we left off yesterday. So let's do Mongo again. So let's go back to our whiteboard. So whiteboard -4. So these were the 2 collections. There we go. And we had users and sections. And so let's see what we did. So let's review the assignment. Let's see that, make sure that you have everything you need to complete this. Okay, so let's see. So first install the database. Looks like most everybody was able to do that. I think most everybody was able to start the server and start the client. Okay, so there it is. So we ask you to create a database called DB_design, which looks like everybody was able to do that. We're working with another database called Whiteboard04, right? But for your assignment, we ask you to create one called DB Design. Then we ask you to insert a couple things, right? Well, we show you, look at are there any collections? At first, there won't be any collections, not until you start inserting. So we walk you through inserting a couple of users, Thomas Sowell, and then inserting Kathy Wood and Adam Smith. And then make sure that they're there, and you'll see the 3 documents that you inserted. Now these IDs will be different, right? Because these are unique identifiers, and they will be different in different machines and different servers. So don't use my IDs. Use whatever IDs you actually get when you interact with the database. Then we showed you about inserting blogs, okay, with certain topics, names, and we're using this author as if it were a foreign key. Okay, so but even though it has the ID equal to some other record or some other document, which in this case it's a user, I believe it's Thomas Sowell. This is not like in relational databases where a foreign key it's referencing a primary key, and then the database makes sure that it enforces referential integrity. Okay, in a relational database, if you try to use a value here for the foreign key with a bogus value, right, that does not match to an actual primary key, then the database is going to stop you and going to say, sorry, no, you can't do that. Right? You can't reference a record that doesn't exist. Here we don't have that, right? Here this is a string, right? But the database is not enforcing any referential integrity, okay? Because this is not a relational database. This is not in a relational database. It is very very important that these references are maintained and enforced, because the main way that you structure your data is by splitting it into multiple tables. And then those tables relate to one another by referencing each other. Okay, so it's very, very important that the relational database, right, its fundamental reason of being, right, is enforcing these relationships, right, making sure that they are correct. In non-relational databases, right, the main focus is not to establish a relationship, right? That's why they're called non-relational databases, right? That's not their focus. Instead, the main way of organizing data in a non-relational database is storing objects that could be fairly complex, that will be containing other objects, objects containing sub-objects, containing arrays of objects of arrays, and arbitrarily complex, right? So you're storing an object, right, and then being able to store the data, embedding the data inside of each other, right? And then when you retrieve it, because they are embedded, it's actually faster to retrieve data that has been embedded. That's much faster than having to join tables, right? That can have quadratic or cubic performance, right? Of having to iterate and doing the mapping and doing the joining. That's very, very expensive. Right? Following references is extremely expensive. So anytime you can get away with denormalizing the tables, right? And embedding things inside of each other, then the better the performance. So definitely a different focus for non-relational databases. So even though we are using this logically as if it were a foreign key, it is not being enforced as if it were a foreign key. It is our responsibility, it's our application's responsibility to interpret this as a foreign key, even though it's not. Okay. Yeah, so we did a few inserts implementing this kind of like this one-to-many, that all these blogs belong to a particular author, right? This is belongs to Tom Sowell, this one to, I believe, to Kathy Woods, and this one to Adam Smith. And again, when we find these documents, these IDs are, again, my IDs. Your values for the IDs and the author will be different. Okay, so whenever I tell you, do an update or remove or delete, and I use specific ID, don't use my IDs because they won't work for you, right? You'll have completely different IDs in your database. Okay. Yeah. So after we show you how to do several inserts and updates and deletes using my data, right? We ask you to do it on your own. Okay. We ask you to insert your own posts, right? And following this structure, right, where the first, you're gonna have a title attribute that's going to be like the title of your post. The body will be a large string, maybe paragraph or two of an actual post, and then the likes, how many likes that post have, and then the blog that it belongs to. Okay, so we ask you to create 2 posts. So we have three blogs, right? One on basic economics, ARK Invest, and Wealth of Nation. And so we ask you to create 2 posts. So 2 posts for each. So a post on basic economics, another one with ARK Invest, and another one Wealth of Nation. So at the end, you're going to end up with 6 posts, right? 2 for each blog. Okay. And then this last field is going to be a reference, right, to one of these blogs, right? So you're going to have two posts with this ID of the parent blog, and 2 posts with this ID, and 2 posts with this ID, right, for the blog. That makes sense? The title, again, this is we're asking you to Google, find some articles on economics and investment, right? Just whatever you find, anything with the titles and body, and so copy and paste your title and your body, and then come up with just some bogus number of likes. And so we're asking you that two of the posts have likes that are less than 5,000 likes, then 2 posts be between 5,000 and 15,000 likes, and then 2 posts greater than 15,000 likes. The reason we're asking you to do the likes, different likes, is that later on, when we query the data, we're going to filter and say, okay, we'll retrieve the posts that are between these likes and these other likes, right? So we're asking you to come up with some values, some bogus random values for the likes. So for the blogs, right, we show you how to retrieve a specific blog if you know their ID. Again, my ID will be my ID. Yours will be something else. Then we are retrieving a blog by their topic. Then we show you how to find a blog, given the providing a Boolean operator, and that the revenue is greater than 115 million or something, a million and a half, and 2.5 million, right? So find blogs that have a revenue between 1.5 million and 2.5 million. Now and then we ask you to do something similar for your posts, right? So again, with the post that you created, right? You created these posts. So we're asking you, well, retrieve all the documents, retrieve all the posts. Then now show me that you can retrieve an individual post. Then, find all the posts for a specific blog, right? So remember, one of the fields in the posts, one of the fields is the parent blog, right? And so retrieve all the posts for a specific blog. Then, retrieve all the posts that are less than 15,000 likes. Retrieve all the posts that have more than 15,000 likes, and then retrieve all the posts that are between 10,000 and 50,000 likes. Okay. So yeah. So again, just for you to have practicing the various queries on your own. Okay. Then we ask you to do a couple of updates, to update a specific blog or blogs that meet a particular criteria, and then we ask you to try it with your posts, right? Then we ask you to remove a couple of posts and blogs, okay? And finally, export the database and submit that that dump to the canvas, okay? All right, any question? All right, if there are no questions, I'm gonna keep and finish the material on MongoDB, and so on Tuesday probably we'll do some more MongoDB. Some students have reached out to me that maybe they might prefer to use Mongo for their project, and so yeah, so I'm gonna discuss that a little bit more. So I'll show you how. Because even whether you're using the relational database or you're using a non-relational database, not only do you have the part where you have to store the data in the database, but to create an application, you have to have a way of extracting that data programmatically. And we saw that for Java, right? We used JPA and we used JDBC. Right, so that's how you programmatically interact with the database, so that you can insert, update, delete programmatically from a programming language. So, if you're going to use MongoDB for your project, then you have to be able to similarly be able to programmatically interact with the database, right? So we'll talk about that. How would you build an application so that you can interact with MongoDB? So that fits nicely into next week, starting talking about the database and how to build these applications. So we'll talk about how is it that you would go about building a small, tiny little application using MongoDB. Okay. Yeah. So it's a nice segue into the next 2-3 weeks. We're going to be focusing. Okay, how do I put all this together and build something, right? All right, so let's finish up the material. Let's see. We had I believe this is where we left off. Many. Let's see. So we had created several users, several sections. Right. Let's see. We had done a db.users.find, and yeah, we had created a couple of folks here. We created Ada was a faculty. Looks like Tim Berners-Lee, T. Lee was also faculty. I guess Alice is a student. Okay, I guess we never made her a student. And we also had created a couple sections as well. And so we had section 1, 3, 4. Okay, these 3 sections. So let's keep working, right? So how about many? How do we work with individual collections, right? So users on their own and sections on their own. What about relationships between records or between documents, right? So, and as you remember, there are many types of relationships, right? There's one-to-many relationships, many-to-many, one-to-one. There's aggregation, there's composition, right? There's inheritance. There's many ways that records or documents can be related to one another, right? So let's talk about one of these, many-to-many. Okay. So here we have an example of a many-to-many, like enrollment over here is a many-to-many relationship between student and section. Okay. Where you can think of one student enrolled in many sections, and vice versa. From the section's point of view, you can view one section having many students enrolled in the same section, right? So you have one student in many sections, And then if you take one section, you can have many students enrolled in that one section. So that's what we call a many-to-many. Another example that I like to give is, if you have an actor can act in many movies, right? So from the actor's point of view, they see a lot of movies. It's like a collection of movies that they've acted in. But from the movie's point of view, you can see many actors that have acted, right, in that movie. Right? So from the movie's point of view, you have a collection of actors that are the cast of the movie. But from the actor's point of view, you have a collection of all the movies that you have acted in. Yes. So that's what we mean by many-to-many. And so if you remember, there were two ways that we could document the many-to-many in a UML class diagram. There was either the class that did the many-to-many implementation, right? Well, first of all, in UML, you could just implement it very easily. You just draw a line and say star star, boom, you're done. That's many-to-many. Okay, and if it's the case that students just want to know the sections that they enrolled in, and from the section's point of view, you want to see all the students that are enrolled in the section, then that's it. That's all you would need. Just one line, star star. Okay. Now, if you want to go beyond that and you want to be able to describe that enrollment, right? That you not only want to know which sections that you're in, but you also want to capture the fact that, oh, I got an A when I was enrolled in such and such a section. Right now, it gets a little more complicated, right? Because where are you going to store that grade, right? That line is not enough anymore, right? But if you want to capture the fact that you got an A, that you really like the core, that course, you want to capture who the professor was that was teaching that, what semester was it. So if you want to capture all these other things, then this line is not enough, right? You need to have some other class, right, where you have all those additional attributes, right, that describe that relationship. So not only is it just a relationship, but now you need to capture all these other fields. So that's UML, right? That's UML. Now whether you leave this line like this or not, right? Whether you have a line or you have a separate class, regardless how you describe it here in UML, you have to also consider that this needs to be written in a concrete sense in SQL, right? So even if in UML, if you just draw a line and do star star, well, that can't be implemented in SQL, right? Because the star star somewhat, conceptually, right? If the student is saying, hey, I'm related to all those sections over there, so that means that I need to be able to capture in a kind of like a set or an array or a collection. I need to capture all the sections that I, as a student, I'm enrolled in. So where would I store all that information, right? Because in SQL, a field can only have one value, right? If this were Java, then yes, you could have an array. In Java, you can declare an array, and that array can have references to all the sections that the student is enrolled in. So from Java's point of view, that's no problem. It could be a line. It could just be a line, and the star just means that I have an array. Yes? But in SQL, you can't do that, right? Because a field can't have multiple values. That's why in SQL, we say that we have to reify, right? That we have to convert that star, we have to convert it into a separate table, right? A separate table that now we're going to capture the fact that this student is in this section by having many records, right, that reference both the student in the section, saying, hey, that student is enrolled in that section, that student is enrolled in this other section, right? So even though you could represent it in UML just with a line and star star, And you can also just plain implement it in Java with nothing else, just because you have arrays. In SQL, you have to have that separate class, that separate table. And that's why we often just do represent the extra class, because we have reified it. Now, when we reify, now we have two options, if you remember, right? One of them was just having lines coming from the enrollment to the student and the sections, and then having basically saying that one many-to-many was converted into two one-to-manys, right? Two one-to-manys, right? And we would say that the way you would document that in UML, because we have reified it, the way you document it is that if you don't have any other fields, right, and just a pure many-to-many, right, which in UML you would use ***, right, but you reified it because you need to implement it in SQL, then you would document it with two one-to-manys, right? But if you had additional fields, right, like the the year that you took it, the grade that you got, the professor who taught it, right, whether you liked it or not, then we would document it with the many-to-many and then dashed. And we say that this is an association class, which is associating a student in a section, and it has all these other fields describing it, right? Regardless, right, you would still implement it in SQL, with additional table, the pointers from a student to, from an enrollment pointing to student in section, and then additional columns for the professor and whether you liked it and blah, 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 right? The grade you got, right? You would still implement the same way in SQL, right? The extra table. But now, because now we're implementing it in an object, in a language, or in a structure, data structure that does support arrays, right? Now we have the same kind of thing that we had in Java, right, where it says, oh, well, in Java and now in JSON, I have arrays, right? So now I'm not only constrained in Mongo because I'm using JSON, right? I'm not constrained with what I can do in a relational database, right, where foreign keys are referencing primary keys, right? Foreign keys are referencing foreign keys. Yes, this is the classical way you would implement it in a relational database. You can also do that here in a non-relational database, like we did for here, right, where when we say that a blog, right, that a blog has an author, right, this is kind of like a foreign key, right? The blog is pointing to its parent. Who's my author? Oh, Thomas Sowell. Who's my author? Right, Kathy Wood. Right, so Kathy Wood can write many blogs, right, and Thomas Sowell can write many blogs, right? So there'd be a one-to-many relationship there. One author, many blogs. So same thing here. Oops. So where you have a child, right, referencing its parent, referencing the primary key. So definitely we could do that in non-relational databases as well, kind of matching what you can already do in a relational database. So non-relational databases can do the same thing as relational databases, even though that's not their focus, right? Their focus is not to split the data with relationships, right? But you can. But because you have arrays, right, you can do what you could do in Java, right? Where a field can have many values associated with it, right? And we represent it using arrays. Okay. So for instance, now instead of having a dedicated collection that references the two, because we reified, right? Instead, we can do away with this enrollment collection, right? Just like in Java, you don't need the enrollment class. You can just use arrays in Java, right? the reason we added the extra table is because in SQL, you don't have arrays, right? But here we're back reconsidering that, hey, now student, instead of having a separate enrollment, students can have their own array and list all the sections that they are enrolled in. And then that array can contain, you know, all the values of those primary keys that they are referencing, right? Same thing with sections. They can have an array of students, and they would contain all the references to all the students that are enrolled in that section. That makes sense? Now, graphically, it will look something like this, right? So this would be the classical way of implementing many-to-many, right? The way you would implement it in a relational database. You can also do it here in a non-relational database, like Mongo. Even though this is not the preferred way of doing it, you can still do it. Although it, as we'll see in a minute, it might be the smart way of doing it, right? We'll see why, right? So graphically, you would have the students, living on their own in their own collection, and sections also living in their own collection, right? And they don't know anything about each other. So students don't know anything about sections, and sections don't know anything about students. Instead, you have an intermediate table that establishes the relationship, that knows who is related to who, right? Saying that the student, right, is related to that section. And this student 2 is also related to the same section. So these two students, student 1 and 2, are enrolled in the same section. Or vice versa. You could say that the same student, student number 3, right, is enrolled in 2 separate sections, right? Okay, so this is what I mean by many-to-many, right? Right, one section has many students and one student has many sections. So this is a classical way of implementing it, and you can certainly do that in a non-relational database like Mongo, right? You could have a collection, a dedicated collection, right, that keeps track of the IDs of each one of the sections. Oops, that's not what I meant to do. Wait a minute. Okay. What I meant to do is this. Yeah, so the enrollments collection keeps track of the references of the sections and the students that are enrolled, just like the implementation you would do if this were a relational database, right? 2 foreign keys pointing to a student section. You could absolutely do this, but because this is a non-relational database and you have arrays, I just want to point out that you have this alternative where the student can now have a field called sections and then list all the sections that the student is enrolled in. So student 1 can be enrolled in section 1. Student 2 can be enrolled in the same section. Right, so these 2 students, notice that are referencing the same section. Oops. Enrolled section 1, whereas student 2 is enrolled in 2 different sections, right? Enrolled in section 3 and 4. Okay, and that's perfectly fine, right? This is a great alternative. This is a great alternative, but you have to be careful though. You have to be careful because notice that if you look at it from the student's point of view, the students know all about the sections, but the sections also know everything about the students, right? Each section knows the students that are enrolled in it, right? So section 1 knows that student 1 and 2 are enrolled in section 1, and section 3 and 4 also know the students that are enrolled in each one of them, right? So basically notice that it's the same information, right? Whether you look at it from the student's point of view or from the section's point of view, the information is the same, right? So this is redundancy. This is redundancy, right? And we had talked about it quite a bit in relational databases, that we are always trying to avoid having redundancy because redundancy can breed inconsistency. For instance, it would be inconsistent that student 1 says that he's enrolled in section 1 and student 2 says that she's enrolled in section 1, and then somehow not have, oops, right? It would be inconsistent to have something like this, right? Where where the information does not agree. That these two students, from their point of view, know that they're enrolled in section 1, but when you look at it from section 1, it only shows that only student 1 is enrolled in section 1. Okay, so that means that whenever you do an update, okay, of students enrolling or not enrolling, right, you have the extra burden of making sure that from the 2 points of view that these two match. Okay, that if you look at it from the student's point of view, yes, they're both enrolled in section 1. If you look at it from the section's point of view, yes, those two students are enrolled in section 1. So that would mean that an update would actually become 2 updates, right? You have to make sure that you update the student's collection and that you update the section collection, right? Because you don't want this to be, you want it to be in sync. And usually that's a bad practice. Whenever you have an update or delete or an insert, that you find yourself that you need to update 2 things because you want to make sure that they are in sync. Okay, that's a flag. That's a red flag telling you that you are walking into an inconsistency risk. Okay, so how would we do this? Let me just show you, right? So for instance, let's enroll one of the students, right, in a section. So let's do that. And that section is going to be an array. It's going to be an array of sections. Okay. Oops. Okay. So let's do that. Let's see. What do we have? We have these sections. We have section 4 here. And for students, what do we have? We have Alice. Let's first make Alice a student. That's easy, right? We can say db.users update. And so this has two JSON. The first one is the selector. I'm going to say I'm going to modify the student whose username is Alice, and I'm going to set. I'm going to set her type is going to be student. Okay, so she's a student. Let's look at the users. There we have. So Alice is indeed a student now. Okay, so let's enroll her in a section. Was there a question? No? Okay. So we have the student. Let's look at the sections again. Okay, let's enroll her in section 4. So the way we would do that is that let's go back to Alice. Okay, and now instead of setting the type, let's set a brand new field called sections. Notice it's plural, and this is going to be an array. It's going to be an array, and we're going to put in here the ID of a section. Okay, so let's go fetch an ID of a section. Let's see. Okay, these are all the sections, right? So let's enroll her in section number 4. I'm just going to copy the ID of section 4, copy, and then paste. Enter. Let's take a look at the users again, and we'll notice that indeed Alice right now has a sections array. See that? Right? So from Alice's point of view, she knows that she's enrolled in that section. The problem is that now the database is inconsistent, right? Because if you look at it from the sections point of view, the section 4 has no idea that Alice is enrolled in, right? So we would have to do 2 updates, right? We would have to update the section, right? For this to be consistent, we would have to say that update section whose name is 04. We want to set, right, the students colon is the ID of Alice. So Alice ID is this one. Let's copy and let's paste it in there. Let's look at the sections again. Okay, there it is. Now it's consistent, right? From the student's point of view, Alice knows that she's enrolled in sections, and from the sections point of view, section number 4 knows that Alice is enrolled in that student, right? So they're many to many. They're pointing to each other. Notice that we don't have an enrollments collection. There's no need for it. There's no need for an enrollments collection, right? Unless the enrollments, you want to store more information about the enrollment, right? You know, what grade you got, right? Whether you like the course, whether, right, what semester, blah, 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 all those kinds of things. Then the only way to do it is by adding an enrollment collection, okay? But we're not doing that. I mean, you could. All right, so let's go for a little further. I did want to show you, what if Alice is enrolled not only in, so let's look at Alice again. Let's take the students. So yeah, so Alice, she's enrolled in this section. How about she's enrolled in another section as well, right? So let's enroll her in a different section. Let's enroll her in section number 3 here, right? So let's update Alice. Alice, where's she? There we go. So update Alice. But notice that this time I don't want to set, right? I want to say, well, the sections array already exists, right? So there it is. So Alice already has an array, and she knows that she's in that section. But I want to add an additional section, maybe this section over here. Okay, copy. So I don't want to set. What I want to do is I want to add, or I want to append to that array, right? So to append to an array, I would use another command called push. So push is going to allow me to append at the end of an existing array, the sections array. I'm going to push another value. So I'm going to remove this ID. Instead, I'm going to paste that that new ID. Let's see that. So that's going to push that. Let's take a look at students. Okay, notice that. Oh no, what'd I do? Oh, I pushed an array. I didn't mean to do that. I did not mean to do that. I had an, okay, no, I want to push. So if I want to push, I don't want to push an array. I want to push a single value. There we go. Let's see what that looks like now. Okay, there we go. All right, so this is what I meant to do. All right, the array, I want these 2 values. Instead, I had to push an entire array. So this is an array that has two values and then another array value in there. I didn't mean to do that. That's fine. Yeah. So again, I'm in inconsistent state, right? Because now Alice is in 2 different sections, but from the sections point of view, only section 4 knows about Alice, but no other section knows about Alice. So I'm inconsistent. So I need to, again, update the sections so that they're synchronized. Okay. So we would try to avoid having to do these 2 updates, either by using a library, right? A library that can handle this for us, right? Or using some kind of stored procedure, right? That could guarantee to me that those 2 inserts or those 2 updates occur in tandem, or maybe even in a transaction, right? So that I would not be in an inconsistent state that, you know, I was able to update the users array, but I was not able to update the sections array. Okay, it would be in a transaction, right? So that, you know, if one fails, the other one fails too, right? And then I would be in a consistent state. Okay, so yeah, set and push. So let's take a look at another implementation that is a little less stressful, right? The one-to-many relationship. So one-to-many relationship is a little bit easier to capture. And here it is. You have a faculty having a one-to-many relationship with courses and a one-to-many relationship with section, right? In that we have that the faculty can author many courses. You know, he can write all the slides, all the homeworks, right, and all that. But they can also teach a whole bunch of sections, right? And they don't have to be the same, right? I could teach a section of a course I haven't authored, right? And I can author a course I've never taught. Maybe I don't want to do that. And usually you document it, you know, with a one-to-many, perhaps even whether it's an aggregation or a composition. Here, notice it's an aggregation. So meaning the faculty can author a course, and if the faculty goes away and goes to a different university, the course can still exist without the fact that that faculty might not exist anymore. Same thing with a section, right? If a faculty is slated to teach a section, and all of a sudden that faculty goes away or doesn't want to teach that section anymore, right? That's fine. We can still keep the section. It could be a different faculty who teaches that section, right? So there's no life dependency between the faculty and the courses or the faculty and the sections. One goes away, the parent goes away, then the children don't have to go away. That's how we capture that with a empty diamond, right? Which is, it's an aggregation. I have a reference to these, but I don't have a composition where if I leave, the other ones leave as well. And so let's consider how we would go about implementing this, right? Now, in a relational database, usually the way we implement one-to-many relationship is that on the many side, we have a foreign key pointing to the one side, to the strong side, right? That's usually the way we implement it. And it's written here as this, right? The children, the sections, and the courses have a foreign key whose value is the primary key of the parent, right? And that's how you would classically implement it in a relational database. And you could do the same thing here, right? In Mongo, and indeed we did, right? In our assignment, that's exactly what author here does, right? The blog has a reference to the parent. Yes, so definitely you could do the same thing in a non-relational database. But because you have an array, now you can kind of like implement it backwards. Well, not backwards, the correct way, or the way we typically think about, implemented in Java or JavaScript or C# or Python. The way we think about it, usually with a one-to-many relationship, is we implement it using arrays, right? Java has arrays, Python has arrays, programming languages usually have arrays, right? So in that case, then instead of having the children, right, referencing their parents, right, can have an array where you can collect all the references to all your children, right? So the faculties can have a reference to all the sections that they have authored, and has a reference to all the courses that they're teaching, right? Right, and so definitely that would be the array would contain references, right, to these objects. But there's yet another alternative, right? And which is, instead of the arrays containing the references to the children, it can actually contain them wholly, right? It can contain the whole object inside of the array as opposed to a reference, okay? So the entire object would exist entirely inside of an array. It would not be accessible anywhere except through the parent going into the array, and then the objects would be embedded in that array. And we call that the embedded data model, right? Now, if we could get away with it, this is the preferred way to go with in Mongo, if we can get away with it. And let's talk about what it means to getting away with it, right? If it makes sense, right? In this case, it doesn't make sense, right? Because, right, and that would mean that if I have a section, well, say I have a course. Now, it would make no sense to store the entire object of the course inside an object that is describing a faculty, right? Otherwise, right, if I want to, have a whole bunch of sections for a particular course, I would only be able to access that course by going to the faculty and then down to the courses, right? It makes no sense, right? I want to be able to have the course all by itself, right, and be able to reference it from a whole different bunch of places, right? Also, it would make no sense that, say, the faculty leaves and I have to remove the faculty record. It would make no sense that all the courses are living inside the faculty. They would be removed as well. They would go away. And then I would say, well, what about all the sections that I opened that are teaching that particular course, right? They would be referencing something that would go away. So, so a better implementation would be to have this one over here, where the faculty is referencing the courses, right, in an array. And if the faculty goes, the courses can exist even without the existence of the course, right? But so let's talk about that. So the classical implementation is that the children have references to their parents, right? So here are the sections pointing to the, through kind of like a foreign key to their faculty, right? And that's absolutely, we can implement that, right? Which is exactly what we're doing with the blogs pointing to the author, or the posts pointing to the blog, right? That's one-to-many. But let's consider this new way of looking at it, right? Of embedded objects, right? Whether we want to implement it either as references, right, or as embedded objects. Yes. So we already said that a better way to implement this would be to have an array. Yes. And I guess the implementation would be as follows, right? Where let's see, this is say you had these two sections, right? You had these two sections with the same faculty. The way you would implement it is that you would have well, actually no, you would have this over here. Let me turn it around. It'd be like that, right? And then this would have an array that would be pointing to both sections like that, right? And maybe change the color here, so that if you had faculty 2 for both, right, you would have, let me copy this like that just to illustrate, right? And let me turn this around, green, and flip this around like that. So these two, right, these green is either using the foreign key pointing to the parent, or the parent pointing to the two children, right, using arrays. Okay. So either you do a reference like we're doing here, or you could do an embedded, right? Something that we can't even do in Java, right? Well, actually, no, you can have classes within classes within classes. You can have private classes, right, in Java. So let's take a look at how we would do it here in Mongo, right? So for instance, whereas it makes no sense for the courses and the sections to live inside of the faculty, it does make sense that a course might contain something that can only exist inside of a course, that it cannot exist outside of the course. It makes no sense to have certain things live outside of their parent. For instance, if you have a course, right, say I have this course in Canvas, and this course has a whole bunch of modules. Here's module 1 for week 2, week 3, all these. Would it make sense for these modules to exist outside of this course? Probably not, right? Logically, it might make sense that if I remove this course, all the content here, it's only specific to this course. So if I remove the course, all the content goes away with it as well. All the questions, all the database questions, all the assignments only make sense for that particular course, right? So yes, so in that case, when it does make logical sense to keep it inside, then yes, we would implement it using a composition. Like course can contain modules, lessons, and lessons topics. And these are compositions, meaning if I remove the course, the modules and lessons and topics go away. If I remove the lesson, then all the topics in a particular lessons would go away as well. So that's composition. So to implement that in a relational database, the way we typically do that is that we have foreign keys that reference the primary key, and then we annotate it as cascade delete, right? Meaning that if you delete the parent record in table lesson, it would cascade down to all the records in table topic, right, where you have a foreign key pointing to that record that you just deleted, okay? But they're in separate tables. Here, because they can have arrays, because you can have an array, now a course can contain an array of courses, right? Course 1 and course 2. But then course 1 can contain an array of modules, and that array of modules can contain module 1 and module 2. And then a module can have an array of lessons, which can contain lesson 1, lesson 2, and lesson 3. And then lessons can contain topics with a whole bunch of, so you understand, right? You have a top level object that contains an array of objects, right, that are all embedded inside of each other. Okay, so for instance, if you have these two topics, they can live inside of a topics field that can contain an array of the topics. And then these lessons, lesson 1, lesson 2, and so forth, can be part of a lessons array inside of a module. And then each module can be then embedded inside of the modules of a course. So that if you remove course 1, you're removing all the modules, all the lessons, all the topics, and poof, they're gone, which effectively implements this composition, right? Now this over here, again, if it makes sense, right, that you do a composition, then this is the preferred way of storing data in Mongo, right? It is the fastest way of retrieving data from Mongo, right? If the data is all embedded, but it only makes sense if it makes sense to embed it, right? Just like over here, it does make sense, but courses and sections make no sense that you would embed them inside faculty, okay? But if you can, like over here, courses and modules and lessons embedded inside of each other, then that is the fastest way of retrieving data, right? Because when you implement this other way where you have references, well, that's expensive, because if you have references, you have to resolve those references, right? Basically, you have to do the join, right? The relational database, you have to join, references that live in different places. You have to do the iteration where you do, is this equal to that? Is equal to that? Joins are very expensive, right? If you have 2 tables, then it's quadratic. If you have 3 tables, it's cubic. So it can get very, very expensive to join a whole bunch of tables. Whereas if you have it embedded, it's kind of the same performance that you would get if you denormalize the database, right? Where everything is already there. You don't have to go fetch and resolve the references. You just retrieve the data in one whole swoop, right? And you don't have to bother going fetching data in other tables. So definitely, again, if you can get away with it and it makes sense, always look for opportunities of embedding data inside of each other. So how will we do this? So let's take an example of embedding data inside. Let's for instance, let's create a module. Right, let's create a module. So this is a brand new collection, and we're going to insert a new module, okay, and has a field name. This is module 1, and we're going to have a lessons. So lessons is going to be an array, and here's our first lesson in module 1. Okay, and for instance, this could be, I don't know, it could be transactions. Transactions is the name of the module, and lesson number 1 is asset. Right, we talk about the asset properties. So the name of the module is asset. Okay. All right, let's take a look at the modules. Modules.find. And there we have it. So we have the first module is called transactions, and the first lesson is on asset. Okay. Now, how about I want another section? I want to add a section to this. Okay. So how do I do that? Right. If these were separate collections, then I would be inserting into a separate collection. But this is not. This array is embedded. Right. So I can't just insert into that lessons collection because it's not a collection at all, right? It's just an array embedded inside of a collection. So how do I manipulate this? How do I add stuff into the lessons? Let's see how we can do that. Right. So what I want to do is DB modules. I want to update a module that already exists. So which one is it? It's the module whose name is transactions. And I want to update this lesson here, right? I want to update this lesson here, and maybe add another lesson, right? So how do I add another lesson? So to add another lesson, we already saw that, right? We can say I'm not going to use set because set is going to override that particular field. I want to push and add another lesson there, right? So we're going to say push, right, into the field lessons, right? I want to add an object of another lesson name on committing, right? Committing data. right? Committing. See that? Let's look at the modules. There it is, right? So the module is called transactions, and I have two lessons, one on ACID, the other one is on committing data, right? I can insert another one, maybe rolling back or roll back. Right, so now I have three different modules. One talks about ACID, committing, rollback, blah, blah, blah. Okay, so how about I want to be able to go in there and maybe add maybe a I want to edit a particular lesson in here. Again, if it were a separate collection, I would just modify a document in a separate collection. But this object is inside of another collection, right? So editing this would be slightly different. So I want to update a module. It's called transactions, right? But let me remove this. Okay, so that's okay. So what I want to edit? So I want to edit this commit here, this committing right there. See that? I want to add maybe I want to rename it. Maybe I want to rename it. Okay, so I need to be able to navigate. First, I'm going to navigate to this particular module by name, like that. But then inside of that module, I want to navigate to a particular lesson whose name is, say, ACID, right? Maybe I want to make it capital, right, instead of lowercase, right? So I need to be able to navigate down here, right? So the way I'm going to do that is I'm going to say that I want to say that it needs to pattern match. The pattern match, the way I can match what I want is that I want the modules whose name is transaction. Okay, I already said that, but also that one of the lessons name is ACID, right? So how do I say? I'm going to say lessons, right? Dot name is equal to ACID, right? So this is the criteria by which I'm selecting a particular name module by name and who has a particular lesson whose name is ACID, right? That's pretty cool. And I want to update, I want to set, I want to modify, I want to set, I want to modify the name, but the name of what? The name of the first lesson, I want to change it to maybe all caps. So how do I do that? I want to set the lessons, and so lessons is an array. It's an array, so I need to be able to say, well, which lesson? So I would be able to say maybe the first lesson, like that, right? And then I want to change the name, right? I want to set it to all caps, ACID. See that? Okay, so this here is kind of like the position, right, of which element in the array I want to modify. Okay, with the square brackets, but actually the syntax is that we don't use the square brackets. We use a dot notation. Dot zero, right? It says that it's the first element in the lessons array. I'm changing to ACID. Let's see if I broke this. Let's see. Okay, let me see. There we go. We were able to modify. See that? We were able to modify all caps. Let's see, is there a question in the chat? Would it also work if you ignore name? Actually, it would. Actually, it would, because there's only one module with the name transaction. So yes, it would work. I did want to point out, though, that you can be very specific on specifying a particular document by specifying a sub-object under there as well. Okay. So yeah, so let's do something a little more interesting. Maybe what I want to do is, I don't want to modify something that already exists. Maybe I want to add a new field in here, right? So maybe a brand new field, maybe a topics field. Okay, and topics, I can set it to be maybe an array of something. Okay, and that array could be an entire object. Like the name of the topic, right, is so ACID is what is it? Consistent. What does ACID stand for? Atomic, right? Atomic. Maybe another topic. name, consistency, consistent. Okay, and all other topics, right? So let me do that. Oops, that didn't work. Oh, the lesson is not asset anymore, right? The lesson is not asset. See, notice that it didn't work because it didn't match. So I do have something that's called all caps. Okay, that worked. Okay, let's list it. There we go. So notice that I have embedded inside of module. For a particular module, I have a whole bunch of lessons. Under lessons, I have a whole bunch of topics. See that? So I can navigate all the way through, right, and modify this object, manually. Now what we'll see in next week is how to, we could do this instead of doing this manually, right? We can create a program, right, that can load this data, modify it in JSON, right, and then put it back in there, which is much more powerful. Right now, I'm showing you how to do it by hand, but certainly it can be much more powerful, once you start using libraries and start using programmatic access to the data. Okay. All right. So just like we set the topic, we set it here, right, to 0. What if, right, we pattern match this asset, right? And I don't right now I'm explicitly saying 0 because I know exactly which one I'm updating. But what if, right, I want to know, well, the one that pattern match with asset here, is it the first one, the second one, the third one? I don't know, right? What I'd like to do is to use the position that was matched here, right? This one already tells me that the one that matched is indeed the first one. It's a 0th. So me explicitly saying 0, it's kind of like an overkill, right? So what I can do, instead of putting a 0 here, I can say $. What $sign means is, whatever lesson position was pattern matched earlier. So acid, this one, pattern matches which one? Pattern matches this first one. See that? Okay. Say I want to pattern match committing, right? So let's pattern match committing. Right? It's this one over here. That would mean that this $sign would not be 0. It would be 1, right? But I'm letting the database do all that work for me, right? By saying $sign, it's whatever this matched, right? So committing. Let's set a topic, and the topic is making data permanent or something. Okay, because we're committing. Let's see if that works. Okay, let's look at the modules. There we go. See that? Now, because it pattern match committing, the topic was set for that particular object, which is position number 1. So that $sign is called the position operator, right? It's an operator, right? That matches, whose value is whatever it is that matches over here. So there we go. So now let me show you. This is setting the actual value of an array of values, or you can add to it. You can append to an array that already exists and has a whole bunch of values by saying push, because, right, this topics is an array that already exists, and I want to push a brand new topic, right? Brand new topic, and I don't know what topic 1, 2, 3, right? So I'm pushing another topic into the topics array, right? If I do that and I show modules, there it is. Now I have 2 topics, right, within the second element in the array of lessons. Okay, does that make sense? Anyway, we will practice this quite a few more times, and what we're going to be starting to look at is, instead of doing this manually, right here at the console, right? Ideally, we would like to be able to do this programmatically. We would like to be able to log in, connect to this database, right, and start manipulating the data, right, by loading the data into memory, making changes, modifying them, and then storing it back in the database, right? It's kind of a little bit of what we already did, but from Java's point of view, right, using the JPA object relational mapping, we would like to have somewhat the same kind of mechanism and capabilities, but right, with working with non-relational databases such as Mongo. Okay. And page down. Right, we retrieve the embedded objects, right? All right, so for instance, let's take a look at this, right? You can retrieve the first lesson, right? So for instance, you can retrieve only the lessons. Right? You say, db.modules, find, and you want well, let's look at the all the modules first. So for instance, I could decide that I only want a particular field, right? And so I can say I want the one with the name transactions. It's that one, and decide that I want only the lessons. Remember that the second argument to the find is a projection, where you say that you want the lessons, right? And so notice that it's only returning the lessons, and only but obviously the ID are always coming back, right? Right, and you have to explicitly say that you don't want the ID, so that's still the same, right? Okay. Yeah, so this walks you through the same, more of using the $, the positional operator. Now there is a limitation. There is a limitation in the positional operator, in that that only works with one nesting, right? So the $ can only pattern match the first array here, lessons, but it could not pattern match nested arrays within nested arrays. Right, so you couldn't use $dot topics $, right? You can't do that, right? There's a limitation in Mongo that only allows you to use the $ operator one level down, right? With that first array that you find here, but you cannot use it, for instance, an embedded array instead of an embedded array, right? So the $ operator does not work with embedded arrays. Although you can use a mixture of the $ operator mixed in with, for instance, this is not valid. You get an error where you have a $, lessons, and then a $, topics, right? That would give you an error. That's not a valid query. But you could use a combination where if you know the exact position, then you can still use the actual value of the position of the element in that array, right? And that's where a nice segue comes in on say, okay, well, if you can't do it manually here at the command line, then definitely you need to take a look at programmatic ways of iterating over this data when the data is way too complex to manipulate manually. Okay. All right, folks. That's all I have for you. On Tuesday, we're going to keep talking a bit on Mongo and perhaps getting started with Firebase as well. But I really want to start talking about how would you use some of this technology to put it together, right, and start building actual applications, right? And obviously with having in mind that we are working on the final project. Okay. All right, excellent. So that's all I had. Have a great weekend, everyone.
Professor, I had a couple of questions.
Yes.
So the first one regarding the quiz from today, I started it this morning without.
Yeah, I saw that. Sorry about that. That there was an error copying over from Blackboard. Yeah,
Yeah.
don't worry about it. I'll publish another quiz and you can take that.
Okay, yeah, thank you. And then about the projects,
Yep.
are we able to team up with members from other sections?
Yeah, so the policy is that yes, you can team up with others in other sections, but the way it works is that so Canvas doesn't have a mechanism for allowing folks to join the same team in different sections. So what we're doing is that you're going to join a team in your own section, right? Even if it's just you.
Yeah.
And then at the end of the semester, we're going to have you report and tell us, which sections, which teams are related in the different sections, so that we can make sure that all the members in all the teams that are related will get the same grade.
Okay, yeah. Thank you very much.
Okay.
Yep.
All right. All right. Thank you.
Thank you, Professor.
Bye-bye.
Thank you, Professor. Have a nice weekend.
You too. Take care.